noise. Okay, so let me screen share. Share screen too. Okay. So here we go. We're starting with interval notation. So a quick reminder that we have inclusion symbols and exclusion symbols. So inclusion symbols mean that something is included in the set. My inclusion symbols have the or equal to. It is a closed dot, and in interval notation, it is brackets. Exclusion symbols means that they are not included in the set. So this is like saying x is greater than or equal to 6. 6 is a member of my set, but this is like saying x is greater than 6. 6 is not a member of my set. It's only the numbers bigger than 6. So a quick reminder of inclusion symbols versus exclusion symbols. So anywhere you have one of these, you would have the others. Anywhere you have one of these, you would have the others. So for example here, this is saying all of the numbers in between -2 and 0. -2 is included. 0 is not included. It is excluded. And in interval notation, I would say that means I'm starting at -2 and going to 0. Let me make that a little bit better. -2 gets a bracket. And the reason why it gets a square bracket is because it had the or equal to. And that's an inclusion symbol, so I do a bracket. 0 is an exclusion symbol, so it gets a parenthesis. And then this is everything in between -2 and 0. So we start at -2 and stop at 0. For interval notation, I always thought of it as a start-stop. Okay? This hopefully is not the first time that you've done interval notation, but, you know, in case it is. So for this one, I would say that we're starting at 3, and 3 is going to get a parenthesis because 3 is not included. So 3 with a parenthesis, and then we're stopping at 8, and 8 gets a bracket. And now this or, we use a U. That is just a capital U. So when you're putting that into more, you put in a capital U. And saying x is greater than 16 means that we're starting at 16, but with a parenthesis and going up to infinity. And infinity always gets a parenthesis. Infinity is not a member of my set. It is just the idea that this set goes on forever. So every time you use either infinity or negative infinity, make sure to give it a parenthesis. Okay. And then remember that for domain and range, domain are the x values or the inputs. Range are the y values or the outputs. Remember his example of a vending machine. For something to be a function, you want to know exactly what output you're going to get given the input. So that's also my best life advice to you guys. Remember, no repeating x's. So the domain of this is going to be all of the x values. Now we're going to put this in numerical order. So we would say -17, they happen to be in order. -4, 4, 17, 32, 44. A few things about this set notation. You should go in ascending order from least to greatest. And you do not write repeats. So if a number repeats, you only write it once down here. Okay. So then for the range, it looks like my smallest range value is 16, then 18, then 45, then 51, 83, 94. I just crossed them off like that so that I knew I used them. Otherwise, I would forget one or skip one. Okay. And so then again, if you're in a table, domain is still just the x's and range is still just the y's. So this is my domain. And this is my range. Same rules apply. If you have a repeat, don't put it, and put your numbers in order from least to greatest. Okay? All right. So then in a graph, domain is left to right, range is bottom to top. In interval notation, we would say that from left to right, on the left side, this starts at -2. -2 has an open circle, which is a symbol of exclusion. So that means -2 gets a parenthesis. The furthest left it goes is 3, and 3 has a closed circle, which is a symbol of inclusion. So 3 gets a bracket. So that's -2 to 3, parenthesis -2, comma 3, bracket. Here you go. And then for the range, we look bottom to top. So it looks like my lowest y value here is -5. -5 is on a closed circle, so that means it gets a bracket. All the way up to the top, the highest y value is 4. If you're on the line, then that's a closed circle, right? Think about it. If you were graphing that point, you would put a dot, a closed dot, so that means it's included. Okay. This one's honestly probably one of the easier lessons up till this point. Now for this one, if we're going to go left to right, our lowest x is 1. It has a closed circle, so I'm going to use a bracket. See how there's no dot here? It's missing an arrowhead. That should be there. If it doesn't expressly tell you that it ends there, then that means that it's going on. So that means this is going to continue going to the right forever. So that would be 1 to infinity. And now here, if we're looking at the range, this is going to go down forever, which means that it's coming from -infinity. And then its highest point is 4. 4 is going to get a bracket because 4 is a point on the line. There is a y value. There is a point that has a y value of 4. And again, this, since it goes down and right forever, means positive infinity on the x, right forever, negative infinity on the y, down forever. Okay. Here we have a rational function that we need to find the domain of. So remember that the deal with a rational is that we can never have x in the denominator. So I need to know what x values would make this denominator 0. So to do that, I'm going to take the denominator and set it equal to 0 and solve. So two numbers that multiply to 30 and add to 11 would be 6 and 5. So then x plus 6 equals 0, or x plus 5 equals 0. Either x equals 6 or x equals -5. So in interval notation, I need all of the numbers. Okay, let me back up. That means that the two numbers that I cannot plug in here are -6 and -5. If I plug in a -6, my denominator will be 0. If I plug in a -5, my denominator will be 0. So my domain is all real numbers except -6 and 5 and -5. So in interval notation, what I do is I say, okay, well then all of the numbers to the left of -6, oops, excuse me, all of the numbers to the left of -6, so that's -infinity up until -6, that's a parenthesis because -6 is not included. Then we'd say all of the numbers in between -6 and -5. And then we would say all of the numbers from -5 or to the right of -5. Everything here is a parenthesis because -6 and -5 are excluded. So this is every number to the left of -6. This is every number in between -6 and -5. And this is every number to the right of -5. So that's how you say all real numbers except -6 and -5. And then for a rational function, the domain, you can't put a negative number under a radical. So what we're going to do is we're going to say, okay, well, where is this greater than or equal to 0? Because that's what matters. We need this to be either 0 or positive. So I'm going to move the 3 over. And then I'm going to divide by the -4. And when I do that, the sign flips. Remember, when you multiply or divide by a negative with an inequality, you flip the sign. So then to write this in interval notation, I would say u is less than or equal to 3/4 would be -infinity to 3/4, excuse me, with a bracket. Okay. All right. These are the fun ones. So a piecewise function is a function defined in pieces. So if x is less than 0, then we use 5x minus 7. If x is 0 or greater, then we use 5x minus 14. So the first thing I had to ask myself here is, okay, is x less than 0 or is it greater than or equal to 0? So here x is -3 and -3 is less than 0. So that means I am in this domain, which means that I use this function. So that means that I'm going to do m of -3 is 5 times -3 minus 7, -22. So now for 0, I'm going to ask myself, is 0 less than 0 or is 0 greater than or equal to 0? 0 is greater than or equal to 0, so then that means to do m of 0, I'm going to do 5 times 0 minus 14, which is -14. And so then for 7, I'm going to ask myself, is 7 less than 0 or is 7 greater than or equal to 0? Well, 7 is greater than or equal to 0, so then m of 7 is 5 times 7 minus 14. 42. I should never do this without a calculator. You should never trust me. 5 times 7. Oh, 21. I went too far. Sorry, I'm just listening to some ridiculousness happen in my house. That's what happens when you have a toddler running around. Okay. Now, graphing piecewise functions can be annoying. So I want to show you the way that I do it. I look at each piece. And the first thing I look at is the domain. So my first domain here is W is less than or equal to -2. So here's what I'm going to do. Now that is an X value. So what I do is at this number on the X, I always will put a dotted line, vertical dotted line, just to start. Now I'm going to graph this. So y equals -0.5x minus 7 starts at -7 on the y. And then it goes down 1 over 2. It's a slope of -1/2, right? Or up 1, back 2. Up 1, back 2. So that is the line -5w minus 7. Now, the reason why I drew this dotted line here was because I only want things that are less than -2. So everything that has an x value greater than -2, I need to erase. And at -2 on the x, I'm going to put a closed dot because this was a symbol of inclusion. So that is -1/2 x minus 7, only when x is less than or equal to -2. Okay, so for the next set, I have -2 and 4. So I'm going to put another little vertical line at 4, just so that I know that my next line should be in between those two vertical lines, because it only exists in between -2 and 4. And the line y equals 1 is a horizontal line at 1. But I just said that I only want that line in between -2 and 4. So I'm going to get rid of everything that is in between -2 and 4. On this side, on the -2 side, I need an open circle. And on the 4 side, I need a closed circle. Inclusion, exclusion. Okay, and then last but not least, y equals 1.5x minus 6, -6. A slope of 1.5 goes up 3, 1, 2, 3 over 2, up 3 over 2, but I only want that line when x is greater than or equal to 4. So I'm going to get rid of everything that has an x value less than 4. And then at 4, I put an open circle. That's it, I'm done. I know I feel like I say that like it's easy, but these are not easy. So we don't need our vertical lines anymore because those were boundary lines that just told me where I needed to be. I'm not going to pretend that these are like super simple. They're not. But I promise you that if you take your time and you look at it in terms of its pieces, that these are not as bad as they seem. Okay. So that was 1.2. Let's go on to 1.3. So increasing, decreasing, constant is just, a function is increasing if it looks like from left to right it's going up. It is decreasing if from left to right it looks like it's going down, increasing again if it's going up. So this function is increasing in this section right here. And then in this section, it's decreasing. And then in this section, it's increasing. Going up, going down, going up. I hate that it doesn't put arrowheads. It's like a pet peeve of mine. And so for increasing, decreasing, and constant, if you're asked for interval notation, you're always asked for intervals relative to x. So we're always looking at these from left to right. So here on this piece, this function starts increasing at negative infinity. And it stops increasing at -2. For increasing, decreasing, constant, we are always going to use parentheses because at a point, especially at a turning point, it is neither increasing, decreasing, or constant, it is turning. So this is not included in the increasing, this is where it stops increasing. Now the next section is decreasing, and it looks like it is decreasing from -2 until about 1.5. And more gives you a little bit of wiggle room here since you're estimating. And then the last section is increasing again, so I'm going to use that U. And I'm going to say it is increasing again from 1.5 until infinity. Okay. And so then end behavior is the idea of we want to know what's happening on the ends. So here, on the left side, as x goes left, that means as x goes towards negative infinity, y is going up toward positive infinity. And on the right side, as x goes toward positive infinity, y goes down to negative infinity. I have a hint for you on these. Those 6 boxes will always be that exact thing every time. And then this is just, is y going up on this side or down on this side? Is y going up on this side or down on this side? Because that's one of those things that I feel like looks way trickier than it is. Okay. Intercepts. Usually if they ask you for intercepts, they're asking you for points. So here, u is my x and f of u is my y. So my x-intercept is at 20, 0. See it right there? And my y-intercept is at 0, -8. So remember, my x-intercept is where y equals 0, and my y-intercept is where x equals 0. So if you're given function notation, to find your x-intercept, or in this case your c-intercept, you're going to make y equal to 0. So 0 equals 4c minus 15. 15 equals 4c when I add the 15 over. And c equals 15 over 4. So my c-intercept is at 15 over 4, 0. And why is that 0? Well, because I plugged in 0 for y. And then my y-intercept is going to be where x is 0. So y equals 4 times 0 minus 15. 4 times 0 is 0. So y equals negative 15. Okay. Now for these, x has a local maximum of, they want to know the y value, that is the highest or the lowest. So a maximum would be the highest. And this looks like it reaches its highest point at about negative 1.5. That's not 2.5, because look at how wide those boxes are. How about 2.1? So then the function has a local maximum of 2.1 at, this wasn't x, it was w, so w equals negative 1.5. If you don't put in that w equals, it's not going to give you credit. And a local minimum, that's the lowest point, a point where it turns around. This looks like it's positive 1.5 and negative 2.1. So a local minimum of negative 2.1 at w equals positive 1.5. So, calculators, let's graph this one. And we'll go over the steps to using the calculator to find everything. Y equals, everywhere I see an R, I'm just going to put an X. So negative 4x cubed minus 37.14x plus 128.59q. Oop, that was x squared. I have to charge my calculator. Now, it asks me on the interval negative 15 to 15. So I'm going to go to my window, not second window, just window. And I'm going to change this to negative 15, my x min and my x max to negative 15 and positive 15. And then I'm going to graph. Oof, this thing is ugly. Cool. I'm going to change the color because I feel like the blue is hard to see. Okay. And then I'm actually going to try to have the calculator pick a zoom for me. So if you press the zoom button and then you scroll down to 0 and you do zoom fit, sometimes it works and sometimes it doesn't. All right, that one's not so bad. The window, the bottom of my window is too low. Honestly, I mean, you could just play around with these until you until you're looking at something that's not like horrible. Window. How about if I make this 3? Getting better. Window. What if I change these like that? Not low enough on the bottom end. I'm in. How about 1500? not 15,000. There we go. Okay, I'll take it. And honestly, like, I don't want you to think that there's some kind of magic when I do these. That's what I do. I just play around with the numbers until I get a graph that looks okay. So the HR intercept, so that's going to be my Y intercept. Okay, if you press second and then calc, you can find a bunch of things here. Now, I'm thinking maybe I went the wrong way for this, because to find my H of R intercept, you can just go to your table and put in 0, because the H of R intercept is where X equals 0. So make yourself a note. Or you could look up at this and say, hey, when X equals 0, this would go away, this would go away, this would go away, right? Because 0 times 4, 0 times this, 0 times that. So I would be left with just 4.54. So 0, 4.54. Now, after that, this is where we're going to start using calculator. Okay, so back to your graph. Now we're going to use second and then trace to get to calc. We want a 0, so we're going to go down to 2 and then press enter. This little cursor that pops up, we're going to move it to the left, anywhere to the left of that, of where it looks like it crosses, and then we're going to press enter. Then we're going to move it to the right, anywhere to the right. And what you're telling the calculator is, find for me the place where it crosses in between this X value and this X value. So I'm saying in between here, find me the place where it crosses the X axis. And now guess just gives me the opportunity to try to get close, but guess is stupid, so just press enter. My 0 is at X equals, what did they want, 3 decimal places? Yep. So negative 11.964, 0. Okay, we're going to do that again. Second calc, 0. I'm going to move my cursor over so that it is to the left of the next 0. See, this is my next 0 right there-ish. Anywhere to the left. Enter. Now, you don't want to go too far to the right, because you want to make sure that you don't cross over this 0 right here. So see how I'm giving it a bound where this 1 0 is a part, but this second 0 is not a part? And then enter again. Negative 0.035. And then one more time, second calc, 0. Left side of the 0. Right side of the 0. Enter one more time. $2.714, 0. Now, local min and local max are going to be found in a very similar way. We're going to go to second and then calc. We're going to do the minimum. So we'll go down to 3 and press enter. Move my cursor so that it is anywhere to the left of that minimum. So here's my minimum-ish, anywhere to the left. Enter. Anywhere to the right. Enter. And again, we're telling the calculator, find me the lowest point in between those two values. Enter one more time. My minimum is, it says a minimum of negative 1362.062 at, this is R, equals negative 7.6. Remember, it's R up here, which is why we have to put R equals right there. Okay. So then to find the maximum, again, it's super similar. Press second and then trace to get to calc. We're going to go down to maximum, move my cursor so that it is anywhere to the left of the maximum I want to find. Press enter, move my cursor so that it is anywhere to the right of the maximum that I want to find. And then press enter. Press enter one more time. A maximum of 100.804 at R equals 1.410. Now, this function is decreasing and then increasing and then decreasing. And I know where it stops because those are these x values. So it is decreasing from negative infinity until this minimum right here, which we know has an x value of negative 7.6. Then it is increasing in this middle part, and we know that it starts increasing at negative 7.6 and it stops increasing at 1.41. And then we know
Just,
after that, yeah.
we don't need the hard brackets for those hard stops.
No.
Okay.
You need parentheses for those.
Just double checking. I feel like I heard something about that, but I just want to make sure. Thank you.
And then the last section is decreasing again from 1.41 until infinity.
What did you do again to find what did you plug in for the min and max in the calculator after you do 4?
That's when you do left of the min, enter, right of the min, enter, and then enter one more time.
Right. So, but that's what I did for the R-intercept. So we're doing the same thing for.
It's the same process. You just, instead of going to intercept or 0, you go to min or max. But the process is the exact same, whether you're looking for 0, min, or max. It's choose which one, whether you want 0, min, or max, and then go to the left and press enter, or the right and press enter, and then enter one more time.
So if I have 3 points, I would have 3 answers?
For intercepts?
Well, I have 3 answers for my R-intercept, but I'm looking for the min and the max.
Well, this graph only had 1 min and 1 max.
Oh, we're doing the, okay, we're not on the X.
Mm-mm.
Oh. I'm confused.
Okay. That one was a lot of calculator work. All right. Rate of change is just a fancy way of asking for slope. I feel like Andy goes through like a long, with your difference quotient, but that's not the way I do these. So when I'm finding the rate of change and they give me 2 x values, what I do is I plug these x values in to get y values. So plug in -8, you'll get 9 times -8, not 8 times -8, 9 times -8 squared minus 6 times -8 plus 6. So -8 comma 618. Plug in 2, 9 times 2 squared minus 6 times 2 plus 6, and you'll get 30. From here, I just do y2 minus y1 equals x2 minus x1. slope. So 30 minus 618 over 2 minus negative 8. Negative 588 over 2 minus a negative 8 is going to be 10. And then negative 58, negative 588 divided by 10 is going to be negative 58.8. So he's right. You can do the difference quotient, but this works too. Okay. And then last but not least, if it asks you for the difference quotient, then you need to use the difference quotient. I wrote it down ahead of time because I was afraid I would forget it, only because this is not how I've ever taught this before. But, I mean, it's definitely preparing you for calculus better. So, if we want to find the difference quotient, we're going to do f of x times h minus f of x over h. So f of x plus h, not whatever I said before, f of x plus h, I'm going to do that separately down here. F of x plus h, I'm going to take x plus h, and I'm going to plug it in for you, is 2 plus 8 times x plus h squared. So instead of a u right there, I put x plus h. Whatever this is, that's what I plug in. Now, x plus h squared, because that's what you need to do next, is x squared plus 2xh plus h squared. TBH, I have that memorized because it's easier than doing this 4 million times, because you're going to see that it's going to be squared a lot. So, you know, it's helpful to just know that one. So then I take this and I make that 2 plus 8 times x squared plus 2xh plus h squared, which is then 2 plus 8x squared plus 16xh plus 8h squared. Okay, so now that we know what f of x plus h is, I'm going to plug this in for f of x plus h. 2 plus 8x squared plus 16xh plus 8h squared. And then subtract f of x, which is this, over just an h. Now, what's always going to wind up happening here, always, is that when you subtract this, you're going to have this 2 and this 2 are going to cancel. 8x squared minus 8x squared are going to cancel. And here we're left with 16xh plus 8h squared over h. So this, when you subtract, everything after the subtraction sign is going to cancel. Now, in the numerator here, I have a GCF of h. So I'm going to take that out. Divided by h. These h's can cancel. And so then my difference quotient is 16x plus 8h. Keeping in mind when I write it back up here that the original function had a u, this is 16u plus 8h. Anybody have any questions?